Good morning and afternoon. I'm going to present disruptive technologies on mobility, raising new opportunities for urban design. The starting point is a post-carbon scenario of mainly non-motorized and clean energy for transport, shared mobility, intermodality, and the gradual introduction of driverless vehicles. The aim of this paper is to investigate changes in urban design resulting mainly from road infrastructure for car use and on-street parking. The main objectives include analyze parameters and indicators from the literature in different urban contexts, set criteria to choose the urban context and case study area, estimate the changes in road infrastructure mainly for car use and parking, carry out a detailed analysis in the case study area, compare the case study findings with initial estimates, and finally assess future scenario proposals regarding change in road infrastructure and urban renovation. Method has 4 steps: the choice of a large and diverse urban agglomeration, then the selection of a case study area, the estimation of road infrastructure changes for car use and on-street parking based on the literature, the assessment of the case study area, evaluating existing conditions and opportunities for urban redesign, and the comparison between initial estimates and redesigned results in road infrastructure. The data raising of the urban context includes 9 attributes in the 96 districts of São Paulo municipality with 11 million inhabitants, a case study area selected in the city center encompassing 4 districts with the greatest potential for the future scenario, totaling 21 square kilometers, a population estimated in 570,000 people, and around 500,000 formal workplaces. Just to give an idea, here we can see the same area compared to A Coruña. Here you can see some of the streets in the case study area in São Paulo, showing the expansion of the sidewalks for pedestrians, the special conditions for parking of shared vehicles, and shared bicycles. Data raising of the road infrastructure in the case study area includes listing, classification, and measurements on all 294 roads, including vehicle circulation area, on-street parking area, sidewalk area and width, bicycle lane extension. Then, a selection of 17 roads was carried out, chosen for detailed redesign and changes in road infrastructure. This is Rua Vergueiro. As for the 17 roads selected for detailed redesign, this is an example of a collector road with the removal of on-street parking and widening of street islands, sidewalks, and bicycle lanes. Driverless vehicles replace the conventional ones, and buses have right-of-way over cars. This is Avenue 23 de Maio, an example for an expressway traversing the case study area. Conventional vehicles use this expressway to go through, but to access the case study area they must be parked at one of the hubs. Autonomous rapid rail transit uses segregated lanes alongside the central traffic island. This is Praça Santo Agostinho, an example for an area currently used for vehicle circulation and on-street parking that can be converted to pedestrian use, including social activities. As an example, here you can see Vergueiro Street, which can be allowed for conventional and driverless vehicles in a segregated way with separate lanes. Vergueiro Street already has underground parking with access for a metro station, which was selected to be one of the hubs, promoting a modal transfer. In addition, this hub will have spaces for vehicle charging, as well as a maintenance area and spaces for driverless vehicles. Changes should occur from the central area outwards gradually, but since the city can't be disconnected, solutions for the interfaces were sought and also for the main roads connecting the city. This figure shows some of the intersections with conventional vehicles approaching the study area, coming from other places where they are able to park and to transfer to public transportation or to a driverless car. In the past few months, most of the world has suddenly stopped due to recommendations for people to stay home in response to the COVID pandemic. Cities worldwide have experienced a significant reduction in circulation, oftentimes the threat or end of congestion. From the second week of March until August first week, the city of São Paulo had a 77% reduction in circulation. Whilst hoping to pass safely through the pandemic, this crisis is undoubtedly an opportunity to rethink the habits on urban mobility. The results add new findings to previous studies discussing disruptive technologies on mobility, their impact on the city, opportunities, and proposals for urban redesign. The proposal for the case study area includes vehicle circulation and on-street parking areas converted for better, sustainable uses, totaling 22.8% of the case study area, 45 average increase in sidewalks width, 500% increase in bicycle lane extension. The main contribution is the proposed method for the assessment of disruptive technologies on urban mobility, including road infrastructure dimensioning and urban redesign, applicable to other cities, incorporating the shift to driverless vehicles and the trend for shared mobility, following the priorities pedestrian, bicycle, mass transit, and driverless vehicles. Gracias. Obrigada. Thank you.